So how to test board, that already today morning Jignesh sir has discussed. So I will not repeat it and not waste time in that. ESP LoRa, if you some of you require the demonstration of ESP LoRa, I will do the demonstration of ESP LoRa. And then after, one platform you have already seen today morning. So sir told the 3 platforms. So out of that, second one is the ESP LoRa, and third one is which we will be using to demonstrate this session, that is Thony microphone IDE. So this Thony is also very good integrated development environment. Pandya sir, in between you just give me feedback if this Thony microphone IDE is not available.
Okay, sir. It is showing, sir, Thony microphone ID.
Okay. So what I will do, I will go slowly so that, your internet, I can match myself with the internet speed. So Thony microphone ID, you can download it from https thony.org. The advantage of Thony is that it provides the editor to write the MicroPython program. And we can also erase and program firmware into the board using menu tools, options, and interpreter menu. Please come later because my lecture is going on. No, I don't require. Now it is working. No. It also provides MicroPython prompt where we can issue commands which run directly on the board. Thony IDE provides different view options, and we can save the programs in a host computer or a laptop or in a MicroPython board. So ultimately, it is a very good IDE to program the NodeMCU. So just now let us go to the demonstration directly without this entire theory, because today morning Dr. Jignesh has discussed much about this theory. So I am starting here. Thony IDE. Is it visible to all of you on the screen?
Yes, sir. It is visible.
Visible. Fine. So today morning, Jignesh sir demonstrated a simple LED blinking program that was typical Hello World program. I will demonstrate here how to read the sensor and then how to display the values. But before that, I will show you the hardware connection. So this is our hardware connection which I have used. Connected one sensor, analog sensor with NodeMCU, and the pin diagram of NodeMCU we already discussed yesterday. In that A0 pin is there. So in NodeMCU board there is a A0 pin, and ESP32 board there are more analog channels are available. So this is how our analog sensor is connected with NodeMCU board, where the sensor output is connected to A0 pin, VCC is connected to VCC of NodeMCU, and ground is connected with ground of NodeMCU. So this is how we have done the connection. And then after, I will run this program. Okay, so now at present we do not have any firmware in this board. So what we will do, we will connect the firmware in the board, and for that I will show you the steps. I am opening the command prompt, and these steps are somewhat similar to the morning session, but these are somewhat in more details. So here I have given erase NodeMCU.bat, and then I have given the COM port. So this is the COM port where my this MicroPython NodeMCU board is connected. Now I will show you this file, what is written in this file. I will make this font somewhat larger so it is visible to all. ESP tool is we are using to erase the NodeMCU port and then %1. So %1 is the argument we are specifying as the COM8. So we are specifying port COM8, and then we issue the command erase flash. So it will erase the flash memory available inside the NodeMCU. So whenever you are using any IDE and whenever you issue any command, then internally this ESP tool is running, and this ESP tool is doing the erasing job. Now we want to program the NodeMCU. That means we want to program the I am issuing command program NodeMCU.batch file COM8. COM8 is the port which we are using to program the NodeMCU. Now I will show you what is written inside this program NodeMCU batch file. Again, I will make the font size bigger so that it is visible to all. Pandya sir, everything is fine. Am I audible, and whatever I am displaying is visible on the screen?
Yes, sir. Yes, sir. Everything is going smooth, sir.
Fine, good. ESP tool again, then we are specifying port %1, that means COM8. We are specifying baud rate at which we are communicating our code is 460,800. We are writing to the flash memory. Flash size is detected automatically. And this is the firmware, the file which was mentioned yesterday by Dr. Jignesh, that there are firmwares are available, and the link was also given in today's lecture. So from that link you will be able to download the firmware. And this is the ESP tool command which you can give to write the firmware inside the NodeMCU. So whatever the IDE yesterday, today morning you were seeing was actually on behind the curtain are using, these are the commands they are using behind the curtain. So whenever you click the button program firmware, then internally it will run the ESP tool command and it will write the firmware inside the chip. So this is how now my board is ready for programming. So now firmware is already written. So now our application level program we have to write. So these two steps are there. One is the erase NodeMCU and another one is a program NodeMCU. Both the batch file I have already uploaded on a Microsoft Team as well as in a Google Classroom. In both the places it is available. At the same time, this binary file, firmware file is also I have uploaded. So if you do not want to download it from the website, it will be available directly from the Microsoft Team as well as from the Google Classroom. Now, first of all, I will show you ESP loader, and then after I will show you the Thony IDE. So in between, some participants are, creating disturbance. So I will mute all again. So I have a ESP loader shortcut here. So I am just clicking on that ESP loader. Then ESP loader will be visible to us. So ESP loader is also one IDE which we can use to program the NodeMCU. So as you can see, it has already selected COM8 port, and then just we have to open that port. And after opening the port, just I have to press the reset button. Then this MicroPython prompt will be available to us. Pandya sir, is it visible?
Yes, sir.
Okay.
It is visible, sir.
All right. So now I will open one program and then I will upload it into this MicroPython. So let me open one program. Let's say I will open the program called, let me take the simple program first, read light sensor.py. Let me check whether if I can increase the font size so that it becomes visible to all. Is this font size visible to all? Whatever the programs is written, import machine, import time, LED equal to machine.pin2 and all that.
Yes,
Because
sir, it is visible.
It's visible, no? Okay, then all right. Because if I increase this, then this will not be visible. So, you know, there is a trade-off. So here LED is connected at pin number 2. So that pin is configured as machine.pin.out. So that pin is configured as output pin. Sensor is connected at ADC 0. So it is written sensor equal to machine.adc 0. So channel 0 is there. Sensor data we read using the function called sensor.read. So it will read the sensor value. And if the data is greater than 800, LED will off, LED.off. That means internal LED will become on, as we have seen yesterday. And otherwise it will become off. And then we print the sensor data. So this is a very simple program I am sending to the ESP. Now you can see here on this side, right side, yellow color, it is displaying the sensor data. This is the program running on the NodeMCU. And actually, this is NodeMCU. And whenever the reading is more than 800, now you can see 1014, 1010, then it is more than 800, so LED has glown. And if the reading is less than 800, LED will turn off. So you can read the sensor and control the devices based on the sensor data. So this simple experiment we can perform with this setup, and this is a program for that. Then after I will open another program. I am opening now this program web server underscore adc status.py. I will reset my NodeMCU because I want to upload the another program. So whenever I will reset the NodeMCU, I will get this command prompt here. And in this program, actually, what we are doing, this NodeMCU is working as a server, and it will continuously broadcast the web page. And in that web page, it will broadcast the sensor data continuously. So what I will do, first of all, I will upload this program. I will send this program to ESP. And then the ESP will try to connect with the network. Once it is connected, it will give the message, yes, now connected to the network. As well, it will also display the IP address 192.168.1.101. So the same IP address you have to specify again here at this point. Here now 102 is there, so now I have to use 101 because at 101 my NodeMCU is connected. And after doing this, I have to upload this program again to the NodeMCU. But before that, I have to reset the NodeMCU. Now I will upload this program again to the NodeMCU. Now both the addresses are same, 192.168.1.101. Here also in our program also the address is same. Now this program has started broadcasting the sensor data on the network. So I will upload, give this URL. I will just copy this URL from here and paste it on the browser. Is the screen visible? ATAL FDP on Internet of Things, EC Department, GEC Rajkot.
Yes, sir, it is visible.
Okay, so voltage on A0 pin is 1.785. So at present, in LDR, a normal, this room light is falling on that, and because of that, it is giving the reading analog voltage on A0 pin 1.785. If I put my finger on the LDR, the voltage will increase because whenever I put the finger, brightness will be there. It will provide a more dark value. So because of that, actually, the voltage will increase. And if I will remove my finger, then again the voltage will reduce. So on a web page, we will be able to broadcast the sensor data continuously with help of this type of a connection. So in this case, actually what we are doing, there is a function we have defined here, Wi-Fi connect function. So this function is responsible to connect my NodeMCU with Wi-Fi. So currently I have a Wi-Fi which is having SSID India and password APEC2004. Just you have to change whenever you are using this program in your PC or a desktop, you have to change this SSID and password. And then after you have to upload this program. Then you have to note down the IP addresses coming here. And the same IP addresses you have to copy back here again. And then you have to reprogram the NodeMCU again, and then it will work. So this program is also uploaded on your team as well as Google Classroom. Yesterday I shared through WhatsApp also. So this program readily you can use at your own place and try with your own NodeMCU. I have connected here a light sensor, but you can connect temperature sensor also. If I will show you one more demonstration. Read temperature, transmit to ThinkSpeak. So basically we are trying to send our data to the ThinkSpeak cloud. So I will open that program. So the same sensor data I will read, and then but I will now connect the temperature sensor because I have done used some equations here. So because of that, now I will change my connections. So in the same board I have temperature sensor available here. If you can see here the diagram of the board, here LM35 is written here. So at LM35, I will, instead of LDR, I will connect this with LM35. So LM35 is a temperature sensor. It's a 3-terminal temperature sensor. You can also do the connections using a breadboard because it's only having a 3-terminal. So either if you do not have this similar kind of a board and if you have a sensor, then LM35 is having only 3 pins. One pin is connected to VCC, another one is to ground, and third one is to the data. So this 3-pin sensor will give you the analog temperature data. So first of all, what I will do, I will upload this program in the NodeMCU. So what I will do, I will reset this. So NodeMCU on this side, there is a reset button. So I will press the reset button. And whenever I will press the reset button, I will get the MicroPython command here. And once I get the command, now I will be able to load the fresh program. Now it is started displaying the temperature values. At present, it is showing 28.77. That is the temperature it is displaying. And you can see now it is not connected to network because I am using here SSID Digital India. So now I will change this to India instead of Digital India. And then I will reset this NodeMCU again, and then we will upload the program. Meanwhile, I will also open the ThinkSpeak account. So because my data will be available in that cloud. And ThinkSpeak is having association with MathWorks. So we can, if we have a MathWorks account, we can log in using the MathWorks account to use the ThinkSpeak cloud. So there are different channels I have created here. So at present, this data will be available in this channel, sensor data channel. So as you can see, the temperature data is available here. Less than a minute. So just now the data is uploaded here on a ThinkSpeak cloud. And initially I have written this program for a Raspberry Pi, but this is only a title, doesn't matter. So at present I have connected NodeMCU, but this actually do not know who is sending the data. Raspberry Pi is sending the data or NodeMCU is sending the data. So this is just a label here. We can also add the widgets here. This ThinkSpeak is visible, Jay sir?
Yes, sir. ThinkSpeak is visible, sir. Meter is fine.
Meter is fine. Okay. I will now add one more widget here. Let me add this numerical display. I can enter any name here in a numerical display. I will enter temperature and I will create it. So this will show me the 29. Later on, whatever the data is continuously getting at interval of 15 seconds, and later if you want to perform some MATLAB analysis on it, you will be able to perform the analysis also. So I will explain this program here. It is also, it is continuously saying the messages that these are the temperatures broadcasted to the cloud with a timestamp. So whenever we are saying that HTTP 1.1 200, okay, that means data is successfully transmitted to the cloud. If my SSID and password is wrong here, then I will not be able to upload my sensor data on the cloud. So in the program, what I have done here is I have written the program to connect with the network. I will try to show it here. Inside the continuous loop, this is the API key I am using here. This API key is very important. So whatever the channel of ThinkSpeak you are using, the same API you have to copy here. I will show you how to get the API. So for this channel, you can see the API keys are available here. So this is the API key which you have to copy and paste there. Then and then the data will come to this channel. Otherwise, it will, it may be broadcasted to some other channel. So the same API key we have to copy and then we have to paste it here. Host is api.thinkspeak.com. While true, inside the infinite loop, we are constantly transmitting data to the ThinkSpeak at the interval of 15 seconds. So sensor is equal to machine.adc0. So it will read the sensor data into the variable sensor. Sum equal to 0. This is a for loop for I in the range of 0 to 100. Sensor data is equal to sensor.read. So it will read the data, do the summation. So what this for loop will do, it will take the 100 readings and do the summation of all these 100 readings. And it takes the summation readings at the interval of 1 millisecond. Sum equal to sum divided by 100. So what it will do, it will divide this by 100. So we have done summation of 100 readings and then we are dividing it by 100. Why we are doing this? To average out any noise. Because of some noise, if your sudden peak is there, then that peak you will be able to remove with help of this type of averaging. Then there is one equation is written here. Temperature equal to sum into 3000 divided by 1023 into 10. Actually, I have to use here not 3000, but I have to use 3300 because I am using 3.3 volt. So 3.3 volt, if I convert that into millivolt, it becomes 3300 millivolt, and divided by 1023 because we are using ADC of 10 bit. 10 bit ADC is having a range from 0 to 1023. So it is divided by 1023, and further it is divided by 10. Because our sensor which we are using is a LM35, it has a sensitivity of 10 millivolt per degree centigrade. So whatever the millivolt readings we have, we want to convert that into centigrade. So we have divided it further by 10. So now whatever the readings after this equation we are getting, that is our temperature reading in degree centigrade, and that is stored in temperature variable. If temperature is greater than 30, we want to turn off the device. Otherwise, turn off means it is an internal LED, so it will turn on actually because it is having a common anode connection. Otherwise, we want to turn off the LED and then print temperature. So it is continuously printing the temperature here. If I change the sensor here, if you can, I will change the other kind of a sensor, like for example, I will connect it with some port here. Let me connect it with a port 2. Now the readings will change. Now it is showing 113. So depending on what sensors you are connecting, so ultimately you need to change the sensor here at A0 pin, and then it will produce the corresponding output, and it will be broadcasted to the ThinkSpeak. So here it is using API key and corresponding name of the field, that is the temperature, and establish the socket. So it is a socket programming, and it will broadcast. It will post it to the ThinkSpeak API. So constantly you will get the data on this cloud. The graph is also shown here. You can see the date versus this temperature. Whenever we have disconnected the LM35 and connected port, suddenly the temperature rise was there. Here numerical display it is displaying, and here also there is a indicator is there. So different widgets you will be able to enter here, and then you will be able to show. Everything is going fine, Pandya sir? Everything is visible?
Yes, sir. Visible, sir.
Okay, fine.
And sir, sorry to interrupt. Our institute net is restored. So if you want to...
but if it is everything is smooth, then I don't want to disturb that. Let us continue. Okay.
Okay.
Let me some other program so that you get exact idea. What I should show you that let me show you DHT22, temperature and humidity program. Okay, this ESP loader is enough. So what I will do, I will now disconnect from here, and then we'll start that Thony ID, so that also you will get idea about the Thony ID also, right? So just I will stop this here. Then I will open the Thony IDE. So this is another IDE, which is very much similar to ESP32, but it will not support the Lua programming. This will support only MicroPython. But this is actually here you are getting the command, and here the same program you can run here, and then you will be able to. So this is a run button. Whenever I will run this, the program will run and it will display the data here. It is at present displaying some 9998, etc. Some values it is displaying. If I connect again the LDR, it will show me the LDR readings. Right? If I put my finger again, the readings will increase. In a Thony IDE, you will also get the graph here. Whatever the readings you are having, you will the graph will be displayed here continuously. So I am changing continuously the light intensity. That's why this value is also changing continuously. So whenever I will put my finger on this camera, at that time, peak will be there. And whenever I will remove the finger, the value will reduce. So you will also get the graph of that readings available here in Thony ID. Let me open another program, this DHT22. I will stop this program and will run this DHT22 program again. So this DHT22 in which I will be using the DHT sensor. So I have this DHT sensor available with me. This is a DHT22 sensor. I will connect 3 wires, VCC, ground, and one data wire with a GPIO 4, or another name of this GPIO 4 is a D2 pin. So I will connect it with a D2 pin. So I will now remove this LDR board and then will connect this DHT22 sensor with the board. So I have connected this DHT sensor with these 3 pins, VCC, ground, and D2 pin of NodeMCU. Then I will upload this program into this. So for that, just simply I have to play this button. I will reset the controller again. Okay, so there is some serial board error, so I will just change the port. Now it is showing the temperature and humidity here. Temperature is 28.8 degrees centigrade, humidity is 37.10, relative humidity it is showing. So constantly it is taking the readings and displaying it over here. This heartbeat sensor program is there, but our I think Puneet sir is there with us. So I will request Puneet sir to show this heartbeat sensor, because yesterday there was one requirement of one participant that he want to know something about the heartbeat sensor. So I will request Puneet sir to take over the session and then continue with the heartbeat sensor. Yes. So I will make you presenter so that you will be able to present your screen.
Am I audible, sir?
Yes, you are perfectly audible, sir. I will give you presentation right so that you will be able to present. I will stop sharing my screen. So you will be able to share your screen now.
Yes, sir. Is my screen is visible to all?
Yes, it is visible,
Yes,
sir.
Yes, sir, it is visible. Just you can go in a presentation mode by pressing F5, and then after you can start presentation.
Okay, so today I am going to present the pulse sensor interfacing with NodeMCU. So going in detail. So this is the pulse sensor available in the market. We can actually design the pulse sensor using a normal LED and the photodiode or a phototransistor. but over here there is a problem. If you can see that my mouse pointer over here, there will be a problem with the noise available from the our 50 hertz electricity signal. So the ready-made module is available in the market where noise cancellation is done for that. So this module is available in around 200 to 250 rupees. So this can be used to detect the our heart rate. And again, it is working at 5 volt or 3.3 volt. So you can interface with Arduino environment, or it can be work with the NodeMCU or ESP32. And let us go move forward. So actually I am going to demonstrate this thing. So this sensor you can interface with our fingertip, or you can also use the ear tip. Before you use this sensor, it is mandatory that you use this protection mechanism, so that it will not affect the circuitry part. So here you can use the band like this, and you can interface, or you can also interface with the ear tip also. Now this is the simple connection. It is a 3-wire sensor, VCC, ground, and one analog out pin will be there. So connection will be like this. And if you can see, there green wire is connected with A0 pin over here right now. And VCC wire you can connect with 3.3 volt or 5 volt, depending on which kind of hardware you are using, either Arduino or NodeMCU. And one more thing, I'm demonstrating this on Arduino environment itself. So pulse sensor library is available. You can use that library to use the ready-made program. Over here, I'm not going to use the ready-made program, but I will demonstrate my own program. So this is the one of the way that you can use this thing. And over here, this kind of waveform will be available to you. So if you can see that pulse sensor waveform will be like this. So it have some maxima and minima, and we have to count number of maxima available within a 1 minute. That will be our bits per minute, BPM. So let us go on to the Arduino environment. So this is the first program. Okay, Jai sir, my screen is visible or not properly?
Yes, sir, it is visible, sir.
Okay, and font size is okay?
Font size is okay for desktop. If you can increase, then it would be better for mobile users.
Yeah, okay. Okay, so now it is visible properly?
Yes, sir. It is very good.
Okay, so over here, this is the first program where I am connecting my sensor at A0 analog pin. I am using the inbuilt LED of NodeMCU that is connected at GPIO 2, and I am having a threshold of 550. See, this sensor is giving a data in the range of 500. Okay, maxima to minima, it is giving the data in the range of 500. So if it is exceeding this threshold limit, then you have achieved the maxima. That is a simple case. As we have seen the default Arduino environment, we have a two function. First is a void setup, and second is a void loop. In void setup, you have to do the setup for the whatever required thing. Like I am using the LED for output. Okay, and I am also doing the printing part also. So that is done at 9600 baud rate. Void loop, that is nothing but a continuous while one loop, you can say. So over here I am doing the analog read part from the sensor pin, and I am saving the data in my variable. The variable is a signal, and I am printing that data on our serial window, terminal window. And I am also doing the conditioning using this if else statement. I am turning on and turning off the LED if I am achieving the threshold. So this is a simple part over here, and in between I am putting a 100 millisecond delay. Again, this delay part is also not required, but if you want to see the data clearly, then delay is required. So I'm going to upload this thing. Before that, I'm also give you the connection diagram over here. See, this is the node MCU where it is connected with the pulse sensor. Three-wire connection. One is connected at VDD, second one is connected at ground, and third wire, brown color, this wire is connected with A0 pin. So let me actually upload my program first. So my program is uploading. Okay, so program is uploaded. I will open my serial window. So if you can see that there is a reading continuously available in the range of 500. If you can see that thing. Now I will put my fingertip on the sensor like this. And now if you can see that the sensor reading, it is going in the range of 600, and at minimum it is going up to 223. Okay, you cannot actually see this thing, but you have to store this data and then you have to do the analysis. Also, you can see the plot window. So I will close the serial monitor window and I will open the serial plotter. So if you can see this thing, you can see these bits per minute. That is a heart rate. Again, it is showing the number of samples. So x-axis is not right now over here. It is just a number of samples that you have taken. So till the time.
Puneet sir, sorry to disturb you. Now plot is visible. Before that, that plot camera was that.
Yeah.
And now it is visible.
Okay. One more thing that during the experimenting, I have just gone through that. If I cover the sensor, okay, right now I am in a prototyping phase. So I have just designed one simple box like this, and I'm just covering my sensor in that. Okay, like this. Okay, and it will give you a result in proper way. Okay, and whatever LED blinking you see over here, it is nothing but it is reaching the threshold value. And for that, it is now what you have to do, you have to count this number of blink. You have to count the number of blink, and within a 1 minute, the number that you can calculate, that will be BPM. So it should be ranging between 70 to 100 something. Okay, so I'm going to upload the second program, and that second program is this. So over here, I will demonstrate this program afterwards. First of all, we'll see the result, whatever it is showing. Over here, I'm just calculating that thing. Within a 1 minute, how many times I'm reaching to the maxima. So I'm uploading this second program over here. Okay, so program is uploaded. Now I will open the serial monitor window. Okay, I have to close the serial plotter first. Okay, and now let us open the serial monitor window. So the reading that you are showing over here, So the reading is in the range of 117 right now. So reading is visible to all.
Yes, sir, it is visible.
Okay. Okay. Now what I will do, I will demonstrate this same thing using one mobile application available on our Play Store. That is an instant heart rate application. So this is the application over here. Now, if you can see, the reading is near that whatever I am getting from my mobile. Okay. If my mobile change the position somewhat, it recalculate again. Okay, so this is not a free application, so ad will appear. So this is the bits per minute that I got from mobile. That is 105. Whatever the band available with us, MI band, fitness band, you can measure in that also. Now the accuracy actually depends on how you press the sensor. Okay, so see, I have just put my finger very softly. If I put my finger hard, then reading will change. So this has to be actually calculated properly, how to put fingers properly. Okay, and I will actually upload this program on our team so that you can do this demonstration with your sensor and your NodeMCU. Okay, and there is a third program where I am just uploading the data, that is bits per minute data on the UB cloud. So yesterday, Vishlani sir has given the all the things related to UB dots. So I have to generate the token in the UB cloud. So over here in a UB cloud, I have to find the API credential. Okay, that API credential you have to copy and you have to put in the program. So if you can see this thing, I have put my credential over here and I'm connecting using my mobile. So I have to put my SSID and password, and the rest of the things that is similar to the program that you have seen yesterday. I have to just upload the program. I have to upload my variable data over there. So this last two line is important for that. I'm just uploading my bits per minute data on the cloud. Okay, so I'm going to upload this program right now.
Process.
So see, right now the data is actually uploading on the UB.s cloud that I can see on my serial window. So right now value is 0. Now if you can see that value is increasing slowly. So right now it is a 29. And same thing you can see on over here. Okay, see. I have developed the rough sketch. So over here, the time taking to upload the data on UB.s, it is too much compared to the number of bits coming in 1 minute. Okay, so reading is not reaching up to the range of 100. So that's why the reading is coming in the range of 9, 10, and that way. Okay, reading is not actually constant. It is maximum of reaching up to the 29. This is the same program that I have demonstrated earlier. This program. Okay. So if you have any doubt in this thing, like pulse sensor, you can ask. Do you have any doubt?
Thank you very much, Puneet sir, for demonstration of heartbeat sensor. It was actually requirement of one participant, and that's why I thought that let us share the this with them. So I would like to show you one more, that sensor to all of you, which is also very much useful for your student project. Just give me confirmation whether you are getting my camera or not. My camera is visible?
Yes, sir.
It's visible. This is a flame sensor. So this is very much useful typically whenever there is a fire is there. So whenever the fire is there, it will give the alert. So if this sensor data will give you digital data, actually it has also 3 pin. Mostly all the sensors are having a 3 pin. You can see here that there is a out pin and then in between there is a VCC and then out pin is. So ground, VCC and out, there are 3 pins are there. And this is actually a device, semiconductor device, which will sense the flame. So this will give us a digital data output. So digital data is very easy to read. So I will show you that program. This Thony in Thony ID, this program is visible to all of you. Digital sensor data. Puneet sir, can you give me feedback? Or Jay Pandya sir?
Yes, sir. Screen is visible.
Okay. So in this case, LED pin 5 is connected. So basically, it will you can connect alarm here. So whenever flame is there, it will energize the alarm. And pin number 2 is declared as an input pin, pin.in, and internal pull-up register is activated. So you don't require to connect external pull-up register. So on pin number 2, we can connect this flame sensor data out, and pin number 5, you will be able to connect the alarm. And status equal to digital sensor dot value, that means it will continuously read the digital sensor. And if it is 1, then status will be 1. If it is 0, then status will be 0. And if status is 0, we want to make the turn off the LED, and that means we want to turn off the alarm. And if status is 1, then we want to turn the alarm on. The same data we can also send it to the ThinkSpeak cloud or a UB.cloud for a remote monitoring purpose. So I think this is what we wanted to discuss with you. If anything is a requirement from your side, just tell me. Otherwise, I will show you one more program related to this. Basically, this NodeMCU is a small device. It will connect a lot of data. It will collect, but unfortunately, it doesn't have any memory to store all this data. So this data somewhere you have to write in a file. So ultimately, what you need to do is, what I will do, I will turn on the camera again so that this smaller chip doesn't have a much memory in that, and if you connect the sensor with this chip, but you don't have that much memory here on the chip. So what we will do, we will connect the sensors here, we will collect the data, but this data we will broadcast it to the PC, and PC will accept the data and it will store it into the hard disk. So I will try to show you that program, both the programs here. Both the programs I have already uploaded on the cloud, but I will show you it here so that you will get exactly idea. So the first program which I will show you is reading a sensor data and sending to the file. So one way is that you can send it always to the cloud. On the cloud, you can store the data. But suppose if you do not want to use the cloud and you want to use your local machine, then also it is possible for you to do the job, right? So I will open the file here. Let us consider this example also. Send heartbeat sensor data to client. Let me open this. So in this case, what we are doing, actually, whatever the heartbeat sensor data which we have, we are sending it to the client because we want to, let's say, save this data for a future reference. For a particular patient, we want to send this data to the server, and then we want to save it there in hard disk, in some Excel file or some other format file. Then what we do, we connect this NodeMCU with the network. We take all these readings. So whatever the readings server was saying that, you are reading the basically analog read we were using in Arduino. In this case, we are using a different command called adc.read. So adc.read will give us the reading, and then we will do some formatting of that data, and then we are just broadcasting this data to the client side. So this is how what our NodeMCU will do. It will work as a server. It will read the data and it will just broadcast it towards the client. Then on the client side also, you require to run some program. So I will show you that program on the client side, what we will do. On the client side, I have another program called read heartbeat PC file. So I will open that in a Notepad++. Try to make the font size larger so that's visible to all. Let me open it in some other IDE. Let me open it into Thony itself, then also not an issue. But otherwise, I can start my Python cell and then we will open there. I think now slightly bigger font size you are getting, right? This file is visible. Read heartbeat.pc.python file.
Yes, sir.
Import sys,
Yes,
import socket, and so basically we can open the CSV file, comma separated value file in a writing mode, And then we can write all this sensor data which we are getting either from heartbeat sensor or from LDR or from temperature, whatever the sensors we are using at the analog input pin. Then we will use one batch file actually to run this entire Python program. So we are basically checking whether how many arguments we are giving with the batch file. So I will also open the batch file simultaneously. This is the same program which I was showing, but this is only for some other kind of a sensor, not for the heartbeat. So in a batch file, actually, we are running the same command again and again. Let me open that file. I have uploaded it into your cloud, but I'm not getting it now. Let me check it there. Yes, here it is. Okay. So it will read some, let's say in this case, we are reading 10 values, but you can always read more than 10 values from this sensor and then store it into the file. So here this is a loop is showing that is 1110. So it will take the 10 reading. Then it will issue this command Python read sensor.pcpy. Then we are specifying this ADC0. So ADC0 is our argument number 1. Which is there in this program. This is our argument 1, that is actually ADC 0. The argument 0 is the name of the program itself. Then we are establishing socket with that ADC. We give the IP address. We specify the port address so that we can do the socket connection. And then after getting the connections, we are receiving this data from NodeMCU, and we will store that data into this CSV file. So let's say if we run this up to 10,000, I can save the 10,000 reading coming from the heartbeat sensors. So depending on number of readings you require, you can run this while loop and get the data from the NodeMCU and store it locally in the file. You can always do this infinite loop. While one also you can do, but whenever you do the while one, you see the amount of data you will get continuously will be very huge. That is sometimes not required. So as and when you require to store the heartbeat sensor data, you can start this program and store some 10,000 samples, and then after you stop your program. So there are two programs. One, this program will run on the PC side, and other program will run on the NodeMCU side. So this program we will call as a client program, and on NodeMCU side, that program is called as a server program. So both will communicate together. So that is what we can do with a NodeMCU. So with the help of a NodeMCU, earlier we started with a Bluetooth. You can connect Bluetooth and you can connect NodeMCU with a mobile phone. That is one idea. Another idea is that you use your local Wi-Fi to connect your NodeMCU with your mobile as well as to your PC and laptop. The third thing is that you want to do controlling anywhere from the world. So you use cloud like Ubi.cloud or ThinkSpeak Cloud or Google Firebase, Amazon AWS. So many clouds are there. And fourth thing is that you make this this as a server and start transmitting data. Get it at the PC side. So use PC as a client. It will accept the sensor data, store it in a file or a display in whatever format in which we like, right? So I think this is what we wanted to share with all of you. We will stop here. If you have any doubt, any query, you can ask. Me and Puneet sir are here to answer your query. If there are further no queries, I request Jay Pandya sir to share important instructions with you, and then after we will end this session here.
Hello, good afternoon all. So let me repeat the instructions that we are sharing with you all from last 3 days. So some important instructions are you should join each and every session of this meeting, and for each and every meeting you will find one session in your MS Team account in calendar, as well as you will also find one link in our WhatsApp group, which is generally shared by the Nagpara sir for material. Again, you can access that material from various websites or tools. First is the MS Team. From the file sections of the MS Team, you can get all the materials that is discussed during the expert sessions. You will also find the programs that have been discussed. To get this material, one Google Classroom is also created, and the credential of that Google Classroom is shared in WhatsApp group also. So you can join to that class by using the link and the code for that class. And one exam link is also posted during this session. That is the test link, or we can say pre-test link, for just for checking purpose.